If you haven't figured it out yet after 133 episodes, modern military aircraft and the weapons they employ are incredibly complex. Sure, it takes fearless aircrew to fly and fight them, and dedicated maintenance professionals to maintain them. But what about all the testing that must be done to field them in the first place? I'm not just talking about aircraft designs here. I'm talking about improved avionics systems, even weapons release testing. In the United States Air Force, that is the job of flight test engineers, which is what we learn all about this week here on the Fighter Pilot Podcast.
Strap in for the Fighter Pilot Podcast, the internet radio show that explores the fascinating world of air combat, the aircraft, the weapon systems, and most importantly, the people. Now, here's your host, retired U.S. Navy fighter pilot, Vincent Aiello.
Hello and welcome to the Fighter Pilot Podcast. I am your host, Jello, and this week, that's right, we learn all about U.S. Air Force flight test engineers with the help of one you've already met. He first joined us for episode 65 back on the B-52 Stratofortress, and then returned to help out with Bomber Month 2021. Mr. Ken Katz, how's it going, Primetime?
Hi, Jill. It's great to be back on the Fighter Pilot Podcast.
Yeah, it's great to have you back. Let's see. So now we've heard from you during Bomber Month, but we don't really know what's new with you. I mean, at the end of episode 65, you were working for a big aerospace company, writing books, flying civilian aircraft. What's new with you in the 2 years since then, Ken?
Oh, a lot of things have been happening aside from the obvious of COVID. I'm still working for the same company, but I have a new job, a really interesting job. I'm leading a team that's developing a digital flight control system component for a major new military aircraft. And this is pretty state-of-the-art stuff. Very cool.
Okay. Yeah, good.
In my civilian flying career, I decided to get a FAA commercial multi-engine certificate. And that was both a lot of fun and pretty hard because with a light civilian airplane, you've got an awful lot of power levers there. You know, when they fail an engine on you, you're busy.
Yeah.
So very cool. My other big news is that I've written a pretty big time book on the history of the B-1 bomber, going all the way back to the very beginnings of the program and, reaching up to the present day. It's been published by Pen and Sword in England, and it just came out in England and should be reaching the United States in about a month and a half.
Okay.
It looks like it's going to be an exciting book. It's about 375 pages with boatloads of interviews and that have been part of it, boatloads of photographs. In fact, 3 Fighter Pilot Podcast guests contributed to it.
Oh, wow.
Chris Wachter contributed to it. Addison Thompson and Bill Moran were some of the many, many people I worked with on the project.
Excellent. All right. Well, we just wrapped up UK month, as you know, so a release in England for starters. That's a good plan. So people can already buy it there. Is that right?
That's right.
Cool. Well, if you can leave me some links or something, we can help promote that for you because you do us favors here on the show. So we'll happily help you promote that as well. You can let us know when it's here in the States.
That's great. And I've got some discount codes both in the UK and for the pre-orders in the United States.
Fantastic. Are those public? You want to just spout them out, or how do you want to handle that?
I don't have them actually handy. We'll post them on the website afterwards.
Sure. Yeah, we'll make people work for it. They got to come find it either on social media or on the fighterpilotpodcast.com. I like that. All right, Ken. Well, you know the drill. Usually, not during Bomber Month, but during the rest of the time, we do some announcements and listener questions. Just a couple quick ones here. First is, let's see, if you are subscribed to our newsletter, you will not see any new emails for a while. We're just regrouping and doing some other things around that, kind of boiling it down to the basics of podcasting right now, just based on some other activities. So you're not going to see anything from us for a little while, but hopefully we'll circle back to that. And then secondly, as I talked about last month, here in about a week or so is the first Blue Angel Air Show of the season. That's out at their winter training grounds in El Centro. It's on Saturday, March 12th, 10 to 4, if I remember correctly. And I'm planning to be out there. So if you are to keep an eye on the Fighter Pilot Podcast social media channels, and we'll let you know if we're going to be hanging out in front of the F-18 at noon or something like that. And hopefully we can meet up. And finally, of course, the elephant in the room. Now, Ken, you and I are recording this on the last day of February, and this is very much still all in the news. Who knows what it'll look like in 5 days when this episode airs. But man, what do you make of this Ukraine situation?
I guess the first thing is that I just don't believe anything on social media. It seems to me it's a perfect channel for misinformation and disinformation. So I'm very skeptical about what I hear, but I guess just kind of at a feelings level as a citizen, as a human being, I think this is terrible. We ended the Cold War a little more than 30 years ago.
Mm-hmm.
And Russia's a great nation. And I was really looking forward that great things would happen. I thought an example of that was the International Space Station, where the United States and Canada and Japan and the Europeans and the Russians were all working together to do something fantastic. And now we're in this. Russia's sliding back into tyranny. The Ukrainians are suffering. They're trying to build a country. It's a country with a lot of problems, a lot of poverty, a lot of corruption. And now the last thing they need is a bloody and destructive war. But there's something that really worries me about this. There's a Russian doctrine called escalate to de-escalate. I don't know if you've ever heard about this.
I have not.
There was an article in the Naval Institute Proceedings in February 2017 about this. I'll read a quote from it. This is really frightening stuff.
Okay.
It's, quote, Russian military doctrine includes what some have called an escalate to de-escalate strategy, a strategy that purportedly seeks to de-escalate a conventional conflict through coercive threats, including limited nuclear use.
Thanks.
I mean, I don't know. I mean, is that something that the Russians take seriously, that they might use some sort of limited nuclear thing if they get into problems with a conventional war? That's a genie we don't want out of the bottle. So I think that's a very frightening thing.
Well, this whole thing harkens back to the end of Cold War and Iraq invading Kuwait. I mean, since when does a big bully just go, push over the kid? I mean, I guess all through school history. But the point is, I thought we were beyond that as a world, and apparently not, because what? Putin's mad that they might join NATO or something? It's crazy. And the news reports, you don't know what to believe with social media, do you?
It's just an ugly, whatever social media is or isn't, it's obviously an ugly situation and people are dying. It's terrible.
I agree. What about this ghost of Kiev, getting back to our military aviation niche on this show? Do you think that guy's real?
There's an old saying that if something's too good to be true, it probably is. I don't know. I'm skeptical, but, could it be? Yeah, I guess it could be. But what do you think?
Well, I'll say this because people have asked my opinion. So I happen to know that there are some DCS remnants from some guy called the Ghost of Something who's got videos. And as you know, Digital Combat Simulator is very realistic looking. So I'm told that someone took some of that and created an internet hoax. Now, that being said, Ken, I won't divulge my source, but I happen to have a very high fidelity source that tells me it's actually true.
Wow.
I got on social media a couple places and said, don't believe what you see and hear, and I'll gladly be wrong. I'm with you. We want a hero to believe in. We want that lone wolf that rises up and vanquishes so many of his enemies, or her enemies, perhaps. But I'm still not convinced. But yeah, I guess time will tell.
Well, that's exactly my point about social media being a perfect channel for misinformation, disinformation. You can do things, and I've seen the DCS graphics. They're incredible.
Yeah.
You can create stuff, and it's just not true, but it sure looks true.
Well, by misinformation and disinformation, of course, you're talking about all social media except the Fighter Pilot podcast, right, Ken?
Yeah, because this is a high-quality outfit. Seriously. Obviously, there are certain things you can depend on. If I read something in Aviation Week, I tend to treat it pretty seriously also. But, the typical Twitter stuff, I just don't believe.
Well, hey, we have been wrong here on this show plenty, and we generally come back around and correct ourselves. So, no pride in that. I'd rather have the right information get out, even if it's afterwards, than stick by my pride. So, yeah, all good.
Absolutely.
All right, let's see. What other announcements? I guess that's it. Ken, you got time for a couple quick questions before we get to the interview?
Oh, absolutely.
All right, so the first is an email from Kevin from Kansas City, who writes, at a certain point, all military aircraft will look similar, even with different manufacturers and countries of origin. The laws of nature do not vary from one military to another, as we already see in automotive manufacturing, and I agree with that. For example, Kevin continues, the MiG-35 and F-15 look alike, and I would add to that the F-18 to a degree. Also, he continues, the F-22, J-20, and Su-57 are very similar. So my question is, in current times and future, how are troops on the ground supposed to know if an aircraft overhead is friend or foe in real time? Well, that is a good question, Kevin, but I think you're putting a little too much credence on the visual ID, because that is one, but it is not the primary, usually, identity method. Now, if you've got troops in foxholes and they see airplanes going over, sure, all they have is their eyeballs, and that's what they're going to do. But in general, you have, of course, electronic modes. We've talked about IFF before, including mode 4. We also have minimum risk routes or profiles. In other words, when I used to fly back to the carrier, we typically were at certain altitudes and certain airspeeds, and that was just one method to identify that we were friendly. Now, it could be coincidence that an enemy could be flying at that airspeed and altitude, but it's just one more indicator. And then the last and the most obvious is just plain old radio communications. Hey, you at this location flying this direction, who are you? You see this all the time, Ken. Hopefully you don't for where you fly your airplane. But if you're coming in off the coast and you haven't been talking to anyone, this happened to me off of Key West a couple of times, like unknown aircraft, at position such and such. Call this frequency and tell us who you are. Have you had that happen to you, Ken?
No, I don't do any, extended over water stuff.
All right. Well, even if you go out for a little while and get low looking at fish or something. But anyway, that would be my response to Kevin. What are your thoughts on this, Ken? Maybe not your specialty, but I'm sure you've thought about this.
You were talking about what I'd call operational ways of getting around it. I think that as we're looking at technology developing, there are also going to be some technology solutions to this. For example, if you can track an airplane from where it takes off, you know whether it's a friend or foe. And think about this. The future is network sensors and artificial intelligence. So even if you have all sorts of sensors, which could be radars in different frequencies, spacecraft, UAVs that have sensors on them, and each of them might just have a tiny little fragment of a hit on a target. But if all that stuff is networked, and then you've got a big brain, if you will, with artificial intelligence that's taking this huge amount of data and trying to come up with patterns of all these little hits from different sensors, and then trying to fill in the gaps in between the different hits, you might be able to track even a low observables airplane from when it takes off, and you know exactly whether it's a good guy or a bad guy. So I think that as we move to this era of networks and sensors and artificial intelligence, that's going to change a lot.
That's a good point you make. In fact, as you were talking about point of origin, as we would call it, back when I would fly our air-to-air stuff, if you had a bogey, which was the comm brevity term for you don't know if it's friend or foe, but then you add the term outlaw, that means, hey, that outlaw, that's a bogey coming from an airfield that we generally know is enemy. So it's probably going to turn into a bandit or a hostile, depending on the ROE. But for right now, we just don't know. But like you said, here's a little extra tidbit of information. Bogey outlaw, not sure, but I know where he comes from, and it's not a good place. Yeah, good stuff. All right, next, let's take a phone call.
Hey, Jello. My name is Garrett. I just commissioned Air Force ROTC out of Penn State University, and I'll be going, hopefully, to pilot training here in the next few months. And I just wanted to call and ask if you had any advice for people going through pilot training or soon to be going through pilot training, how they should determine whether they should track fighter bombers or heavies or even helos. This is just for the Air Force specifically. I wanted to see if you had any insight on the differences between, the lifestyle, that be it, travel, time away from family, workload, and things like that. It'll be different working with the crew versus being alone. If you had any insight, I'd appreciate it. Thanks. I love the podcast. I listen to every single episode. Thanks so much.
All right, Garrett. Well, first off, congratulations. You've got an awesome career ahead of you, and I am jealous. So have at it, get after it, and make it fun and live every day to the fullest. Now, I was not in the Air Force. I could give you my Navy opinion, but instead, I reached back to some former guests who were Air Force guys. And Ken, don't fall asleep on me because I have a lot of reports. In fact, Garrett, I think one of them is going to call you or at least reach out to you and give you his opinion. But I'll start with Wacky. He was our B1 guest. Ken just mentioned him a little bit ago as a fact. He said, my advice is to be humble and focus on being the best you can in trainers and not worry so much what might be in the assignment drop. For instance, my T-38 class had 6 of us, splitting 2 fighters, 2 bombers, 2 first assignment instructor pilots. Being in the top half and still getting a bomber bummed me out at first. But ultimately, I had an amazing flying career in the bone. As to lifestyle, far too early to predict. Each platform deployment cycles have varied wildly over the past 25 years. Luckily, you have plenty of time, Garrett, an opportunity to talk with pilots about this once you are established at the pilot training base before deciding. And that last sentence that Wacky makes is going to be repeated over and over. Now, next, I also heard from T-Day. He had just landed from a long airline trip to Incheon, but before he crashed out, he provided his advice. And he says, he broke it down by platform here. He says, fighter attack, mostly single seat environment. If your goal is adrenaline driven and you want to be the tip of the spear, this is for you. Requires a lot of self-drive. Be ready for long study hours, long briefs and debriefs. That's absolutely true. And recurring deployments of 3 to 6 months at a time to hot spots all around the world. The camaraderie and the esprit de corps is second to none. And living conditions depend on deployment locations and theater of operations. And then T-Day, being an F-16 guy, says bombers, multi-crew environment, fewer long flights and longer simulator missions, some deployments, but the fifth generation, like the B-2, they tend to be based in limited locations due to their sensitivities. Living conditions depend on deployment locations and theater of operations. So, for example, Garrett, if you wanted to fly the B-2 and you happen to be from Missouri, I think that's probably a good choice. And then he continues, tanker transport, multi-crew. Tankers are in limited supply and high demand, so lots of deployments to support strategic missions and tactical missions. Transport, inter-theater, tactical airlift C-130s tend to go into a theater of operations and stay. Living conditions depend on deployment locations and theater of operations. And a lot of the C-17s tend to go on 2 to 3 week rotations in and out of theaters. Speaking of that, I did also put this to Voodoo, but did not hear back from her in time. And let's see, they can have better accommodations and recreations. He wraps up here, T-Day does. This is a very broad-based overview, and there are always exceptions, such as 2-crew F-15Es, Special Ops C-130s, and Rotary Wing HH-60S, which are limited supply and high demand. All right, you still with me here, Ken? I got 2 more.
Yep.
Okay. Then I heard from Supa, who flew the A-10. He said, as for track select between the fighter, bomber, or heavies, I could say don't worry about that yet, but that's not very realistic. You are thinking the right things, lifestyles, bases, etc. What you really need to do is ask questions of all the different instructors from as many different flying communities as you can. Sound familiar? Do this with an open mind and maybe be ready to take some advice with a grain of salt from pilots who may want to tell you about a community they are not in. Hint, hint, previous supplier. Also, do not write off fighters as, quote, being alone versus having a crew. You are always with a flight lead or wingman. You work, train, and deploy to combat with your entire squadron. Like I said, get as much information as you can from as many different instructors as you can. And then finally, I heard from Buck, our AC-130 guest, and he said, I highly suggest you approach pilot training with an open mind about all of the different platforms. UPT is more than just teaching you how to pull back or push forward to make houses smaller or bigger. Fortunately, there are instructors from across the platforms and communities. Use that interaction and experience wisely. Pick their brains about the pluses and minuses of each community so that you can pursue an assignment that will be the most rewarding for you. And as you start flying, you will gain immediate insight into the dynamics of actually flying. Not everybody enjoys pulling G's or going upside down or wearing a helmet and a mask. Others find they enjoy dynamic maneuvers and can't imagine straight and level for long periods. Give yourself time to process as you go through training and determine what type of flying best fits you. As for workload, every community is working hard. I agree with that. That was going to be my response if I didn't hear from everyone. Fighters fly shorter sorties and when not deployed, spend more time at home, but I can assure you they spend a large amount of time and very long days preparing in the vault and debriefing each sortie, becoming as good as they possibly can. Tankers and strategic transports will be away from home more, but some really enjoy it and see opportunities for other parts of the world. And then when you are home, you're preparing for missions. Employing a tactical aircraft single seat is challenging and highly rewarding when done correctly. Similarly, leading a crew in the accomplishment of a complex mission also takes great skill and is equally rewarding. Oof. All right. I hope everyone's still with me. Garrett, as you can see, you opened the proverbial Pandora's box. If you want to email me at questions@fighterpilotpodcast.com, I can forward you all these and you can read them yourself. And again, I think T-Day is going to call you because your number came up in the phone call there. So good luck. Have fun. Ken, if you're still with me, anything to add to all that?
Well, as a non-pilot who got out of the Air Force over 30 years ago, I'm not the best guy to do this. But I will give some general career advice.
Okay.
A lot of things that you do in your life aren't always exactly what you plan to do, but opportunities that come up. And sometimes those are neater things than what you thought. And whatever it is that you do, it's a function of the good people that you work with. You try to be professional and do the very best at it. That attitude is more important than, let's say, what particular kind of airplane you fly. Because, when you talk to people who do a whole range of things, they all seem to like what they do.
Here, Ken. People are going to think I put you up to that because I constantly ask that question and tell people when they're listening to the show, like, look, I keep going back to Niles. He was our E2 NFO, right? And he wanted to be a fighter pilot, but he loved it. So I think hopefully, Garrett, you will find that you will get to the community you're meant to be in, whether that's karma or God or Darwin or whatever you want to decide, then you should hopefully thrive there as long as you have the right attitude and give it your all. So good luck. Have fun. Thanks for the phone call. All right, Ken. Well, gosh, that was really interesting, all those announcements and listener questions, but let's get to the main event. And by the way, this is your interview. I'm kind of the co-host here. I thought you do a real nice job, as we'll hear in a second. Any thoughts, big picture-wise, before we listen? Any alibis or caveats or anything?
Well, I really enjoyed talking with Eileen. We have so many common interests. We didn't work together. We were on opposite sides of the flight line, but we were at the same base at the same time. So that kind of common frame of reference.
Oh, for sure. She's really great. So without further ado, let's learn all about U.S. Air Force flight test engineers with Ken and retired U.S. Air Force Colonel Eileen B.J. Bjorkman. Here we go.
The military conducts development testing to verify that new aircraft and other systems meet requirements and can do the mission. Today on the Fighter Pilot Podcast, we will talk to retired Air Force Colonel Eileen Bjorkman, who has been a leading figure in U.S. Air Force flight testing for almost 40 years. Hi, Eileen.
Hi, Ken.
Welcome to the Fighter Pilot Podcast. We're looking forward to having some interesting discussions here.
Thanks for having me on.
Let's start off with kind of the usual Fighter Pilot Podcast question, which is where are you from? How'd you get into the Air Force? Where'd you go to college? How'd you get to where you are today?
I'm not really from anywhere. I always tell people that my dad was in the Air Force, so I moved around a lot as a kid. Right after my senior year of high school, my dad retired from the Air Force and got a job with Boeing and moved out to Seattle. I was only 17 at the time. I had graduated from high school a year early, so I decided just to go ahead and move out to Seattle with the family and enrolled in the University of Washington. Graduated from there in 1979 and spent about a year working in the private sector. Was getting a little bored and was looking around for a job. I interviewed again with Boeing. I had interviewed with them previously and had gone to another job. And I interviewed with Boeing, and then the Air Force was there. It was the recruiting center at the University of Washington. And even though I had graduated, I was still able to use the recruiting center. So I was there, like I said, and interviewed Boeing, talked with the Air Force as well because they were there. My intent was originally just to talk to them, and the next thing I knew, I was filling out paperwork and signing up to go for tests and a physical and all kinds of things. And a few months later, I was in the Air Force going to officer training school down at Lackland, Medina, Texas there at the time.
What was your first assignment in the Air Force?
My first assignment was actually to go back to school and become an engineer. I had started out in engineering and switched to computer science my junior year. When I was coming in the Air Force, they were short on engineers. And so they were taking people like me who had the first 2 years of engineering school, calculus, differential equations, physics, that kind of thing, and sending us to AFIT to get a second bachelor's degree in engineering and then go on from there. So it was an 18-month program.
AFIT is the Air Force Institute of Technology?
Yes, Air Force Institute of Technology. So yeah. After I graduated from AFIT, then my first real assignment was at Holloman Air Force Base, and that's when I got my first real introduction to flight testing.
And what were you doing at Holloman?
We tested inertial navigation systems. We didn't have any aircraft of our own. The 4950th Test Wing at Wright-Patt at that time had C-141s and C-130s that they would bring down to Holloman. We would put the inertial nav systems on these big pallets and roll them onto the back of the airplane and then fly around and see how they did. And inertial nav systems take a while to test because they have a drift characteristic. And so you can't just fly them around for 10 minutes to see how they're doing. You have to actually fly them for 3 hours or 6 hours or even longer at times to really get an estimate of their overall performance.
I think that inertial navigation systems are one of the most amazing technologies that I've ever touched in my career.
Yeah, they're almost magical. Yeah.
They just feel where they're going, and then they don't need any inputs from anything. Of course, if you don't give them some input, they drift, but they just feel where they're going, and it's amazing.
Yes.
What was your next assignment after Holloman?
So after Holloman, I was at Holloman. I applied for test pilot school. I had a couple hundred hours of flying time in the back of C-130s and 141s at that time. Had my bachelor's degree in engineering. So I went ahead and applied for test pilot school and got selected. They picked me up for the joint program where they send you back to the Air Force Institute of Technology for a year. The program is now, I think, a year and 15 months. When I went through, it was a year. Went there first to get the coursework for a master's degree, and then went out to test pilot school. While I was at test pilot school, I also collected data to finish up my master's degree, to finish up the thesis for the master's degree.
Now, I'd like you to discuss something. There's a common belief that test pilot school graduates test pilots, which of course it does. But engineers also go and they become graduate level flight test engineers, which is somewhat related to being a test pilot, but it's different. So what are the differences and the similarities between becoming a test pilot and becoming a flight test engineer?
The curriculum is actually quite similar. The academics are really 100% the same. You go through all the same classroom kind of, as far as aerodynamics and flight control systems, all of those kinds of things. It's exactly the same. The flying is a little bit different. The engineers fly some flights that the pilots don't. The pilots fly some flights that the engineers don't. A lot of times, though, the engineers and the pilots are flying together. So the pilot will be actually flying the aircraft, and the engineer will be taking data, monitoring the test, helping the pilot to stay on conditions, making sure that the appropriate test points are being, everything is getting collected and all the data is there. And sometimes the engineer would be sitting in a control room instead of with the pilot. So especially if you have an aircraft that is, say, just got an instructor and a TPS student pilot in it, you might have an engineer sitting in a control room collecting that data on the ground instead. But like I said, the curriculum, though, itself is all very similar. It's just that sometimes the pilots are flying the airplane and the engineers are collecting data, whether they're on the ground or in the back seat. That's probably the simplest way to describe it.
In my career, I found that one interesting thing is that test pilots, in my experience, spend a lot of time away from the airplane because they're doing things like, for example, working in simulators. And so flight test engineers tend to spend more time with the airplane itself, configuration, instrumentation, things like that. That's an area where, making sure that the aircraft is ready for flight in every which way. That's one of the areas. The other thing is that engineers tend to be more involved with the analysis and reporting. Although, of course, the test pilots are also, and I should add, test navigators are also involved with that. But that usually the engineers are taking the lead on writing the reports.
Yes, definitely. I would agree with that. They also typically are more involved in the test planning, the upfront test planning, even before you get to the airplane.
Yes. And engineers tend to run the setup of the control rooms, the range, things like that. In my mind, it's a complementary relationship between flight test engineers and the pilots and navs.
Yeah, very much so. And one of the reasons they started putting engineers through the school, the first engineers started going through in the early 70s, in the Air Force anyway. One of the reasons they started putting engineers through the school was because they had so many times where the test pilots would be trying to talk to engineers about like a problem they saw in the aircraft, or the engineers would be trying to talk to the pilots about something they wanted them to do, and they didn't speak the same language. They were often talking past each other. So that was the idea was, hey, let's send engineers through too. They're sitting in the airplane with the pilots. They're doing the same maneuvers. They're learning all of that. They may not be flying the maneuver themselves or, having to actually make comments themselves on something that's going on, but they're seeing everything that the pilot's seeing. And now when the pilot says something, they can translate that better.
What'd you do after graduation from test pilot school?
So after test pilot school, I went down to the F-16 Combined Test Force, and I worked on the Lantern project. I was the lead flight test engineer for that project, and Lantern stands for Low Altitude Navigation Targeting Infrared for Night. And originally, it was developed on the F-16 aircraft, so the system itself. It wound up going operationally on the F-15E first, but the actual development of the system was done on the F-16.
I was out at Edwards at the same time you were doing that, and I knew of you, but I don't think I really knew you, and I doubt you knew me because you were one of the gods. You were a captain with a test pilot grad school graduate patch, and everyone knew them. We were the weenie lieutenants who were helping out in a dozen and one ways. Also, we were at the opposite end of the flight line because I was down at Strategic Systems.
Yeah.
I did know of you more than I knew you.
That sounds about right.
That was kind of fun out there. Do you remember things out there like the Pancho Barnes party?
Oh, yes, definitely.
Let's tell the listeners what that was all about.
So the Pancho Barnes party was an annual event. And I'm not sure exactly when it got started. And I'm not sure it was always annual. I think it was sort of irregular. So I do have a mug from, I think it says the 9th or the 10th Pancho Barnes, annual party. Should I talk about Pancho Barnes, who that is
Sure.
first? So Pancho Barnes, she was around when Chuck Yeager and the original Right Stuff kind of pilots were around back in the 50s and 60s time frame. And early on, she owned, I guess you'd call it a bar, right, near the base property. And she had a riding club. It was called the Happy Bottom Riding Club. And a lot of the test pilots started hanging out there. And she was actually a pilot too. She was a race pilot back in the 30s. She was very big in aviation in Southern California. And so the test pilots just sort of naturally gravitated to her and her bar and her riding club and everything. And so, years later, there used to be, I think, a hotel there. There was all kinds of stuff there. And years later, of course, it had all fallen into disrepair. And it's out near the Rosamond dry lake bed. It's out kind of in that direction. It's not on the lake bed, but it's kind of in that direction. So at some point in the I think late 70s or early 80s, they started opening it up to allow people to go out there and have parties. And I remember having a party out there that was not the official party. We could just go out there and have a party. We could take a keg out there and have a party. But they also had these official events, and there was lots of alcohol. And they actually had buses that would pick you up from the main base and drive you out there. So you didn't have to worry about drinking too much. They would drive you back to the main base at the end of the party. It was always a great time.
I thought one of the coolest things about being at Edwards Air Force Base was just the sense of being part of history.
Yes.
That this is amongst the most historic places in aviation history. And when you're assigned out there, you're part of it.
Definitely.
Adding to that history in some little way or another. Very cool.
Do you mind if I say one quick story about history?
Oh, please.
So it was actually a historian that kind of sealed the deal for me on going to Edwards in the first place. When I got to Holloman and I was flying and I was a flight test engineer, I thought I was interested in going to Edwards. I thought I wanted to go to test pilot school. That was kind of my, where I was going. But we had Richard Hallion, who later became the historian for the whole Air Force. He was at Edwards at the time. And he came to Holloman and gave a presentation at an AIAA meeting, I think it was, in the evening. I remember going to this presentation, and he gave this, great presentation of all the history at Edwards and everything that had happened. And when he got done with that, I was like, I have got to go to Edwards. That like sealed the deal for me. So I've always said it was a historian that really got me into test pilot school, because after I saw him, that was my number one goal.
I knew Dick because he was the chief of history out at Edwards when I was out there. And I mean, he's written the book that's kind of the standard history of flight test.
Yes.
I mean, he's a great guy. So we'll go through your career more in detail as we go through here. But right now, you're in an executive position in Air Force flight testing. So could you just give an overview of the scope of flight testing and development testing, which is not all flight testing, within the Air Force, and what are some of the bases and units and facilities?
Yeah, so I'm at the Air Force Test Center, which is actually based at Edwards, but we have multiple organizations, like you said, throughout the United States. There are three main locations. We have our 412th Test Wing at Edwards, we have the 96th Test Wing at Eglin, and then we have Arnold Engineering Development Center in Tennessee. So Edwards is mostly focused on the aircraft testing itself, performance, flying qualities, kind of the basics of how the aircraft operates, avionics, integrated systems. Eglin tends to focus on munitions. That's not entirely what they do, but their focus is on munitions and integration into the aircraft. They also do a lot of work with command and control systems, and they have a cyber test group there as well. And Arnold operates a lot of wind tunnels. They do both, kind of your standard aerodynamic performance kind of testing and modeling, and they also do a lot of work with engines. And they can do everything from subsonic all the way up to hypersonic testing. And then we have our test group at Holloman, which is assigned to the Arnold folks. They have various ground and flight test facilities there as well. So they do radar cross-section testing, they do a lot of GPS testing, and they have the Holloman high-speed test track there, which you get all kinds of everything from missile testing, ejection seats, flares. I mean, there's just all kinds of stuff that they do there as well. And then we have a bunch of little facilities scattered throughout the country. We actually have a wind tunnel that you can get to on the metro in DC. It's called Tunnel 9, and you can get to it. It's up in Maryland. And then we've got another wind tunnel that we got from NASA a number of years ago that's up at Moffett Field. And then we've got, like I said, we have all sorts of little facilities scattered all throughout the country. So about 18,000 people total.
The Air Force also works with the Navy and with NASA, so you have access when needed to other facilities like China Lake?
Yes. We work quite a bit with the other services and with the Navy, especially. China Lake, we work very closely with China Lake.
When I was at Edwards, I used to work very closely with the Navy at China Lake. I think one of the most interesting Air Force test facilities is down at Eglin, which is the McKinley Climatic Laboratory.
Yeah, I forgot to mention that one. So, yeah.
I did climatic testing on the V-22 Osprey, and that was probably the single most interesting, challenging thing I've ever done in my career. That was really cool.
Yeah.
Let's talk in detail about your experience as a flight test engineer. What was it like to attend test pilot school?
It was a lot of work. It was very challenging. It was probably the most challenging thing I've ever done because it's a very compressed timeline. A typical day, you get up in the morning early, or you go and you fly one flight, maybe two, depending upon the schedule. You come back and maybe grab a quick bite to eat, and then you're in academics all afternoon. I think they've changed that up a little bit now. I think now they do some of the academics in the morning and fly in the afternoon. But when I went through, it was pretty much flying in the morning once or twice, academics in the afternoon. And then your flights, you're not just flying, you're usually collecting data. You've got to write some kind of a report. Sometimes it's just a quick, short summary of what you did. Other times you have to actually go and analyze some data and write a report on that. Or you're using that data to write a bigger report because you're collecting a whole bunch of data and then you're going to put it all together and write a bigger report. So you're working with a team most of the time. So some stuff is individual reports, but in other times you're working with a team and you're putting together a team report. So when you go home in the afternoon, so you've already been up between 9 and 12 hours when you actually go home for the afternoon, but you're not done because now you got to get ready for maybe a flight the next day, or maybe you're not flying, but maybe you're going to be sitting in a control room and you have to be working with the pilot to get the test cards ready for the next day. You might have to be studying for a test. There's just, reading materials to, for the academics the next day. And there's always something. So, 12, 15, 16-hour days were pretty typical every day that I was going through there. And then usually working on the weekends as well, not actually going into school, but, having to catch up on the weekends to do things. But it was also a lot of fun, though. I learned a lot. My classmates and all, we were very tight. We had a lot of parties. That was, in fact, we used to invite the instructors to our parties, and they liked our parties so much they used to ask us when we were going to have another one. So we did have a very fun class, even though it was a lot of work. There's also trips that you go on. You're not just at Edwards the whole time you go. And again, they've changed this up a little bit, I know, over the years since I went through. But you go and visit other test facilities. You visit other test organizations. You fly with them. You go in their control rooms that you learn how they do things. You go to manufacturers and see how aircraft are built. And you maybe get to talk to some of their test people as well and see how they do their testing, say at Boeing or Lockheed. There's usually a trip overseas as well, where you can go and fly, with another organization overseas. They also bring in a lot of different aircraft to fly. It's a little different now. Mostly they bring in civilian aircraft. When I was going through, it was mostly military aircraft, but we just don't have the variety of military aircraft anymore. So like when I was going through, I flew in the A4 and the T-34. And I could go down the whole litany. But the whole idea is you fly all these different aircraft so that you can learn how different aircraft feel and what designs are good versus bad and how aircraft have evolved. And so when you get into a new aircraft and you see something, you're not necessarily seeing it for the first time because you've probably seen something that looks a lot like it in another aircraft that you flew because you've gotten to fly in so many different airplanes.
I took advantage of that, and I wasn't even a student at the school because the Strategic Systems CTF was right next to the test pilot school.
I remember that, yeah.
And whenever a new airplane would fly in, and they were coming in all the time, I would go, that looks really cool. I wonder if I can scam a ride. And I was the most annoying mooch of rides. The amazing thing is that as a guy, and I only spent 4 years in the Air Force, and I was non-rated. I wasn't a pilot. I have more types of military aircraft in my logbook than most career military pilots do.
Yeah.
I think I got to fly in 20 types of aircraft, which was fantastic. It wasn't just fun. I mean, and it was fun and cool. But when I got out of the Air Force, I was at Boeing. I was testing the V-22 Osprey, which is a pretty unique aircraft. And one of the things that was just fantastic is I had this huge database in my brain of different kinds of aircraft. And that was so valuable.
Yeah, that's why they do that it basically puts this database into your brain. And we had very specific things that we were looking for when we would go. We weren't just up there flying. In fact, we had to write a little report about every aircraft that we flew in. It wasn't long. That wasn't like 20 pages, but it was several pages. You'd have to come back and write up, about the flying qualities or the systems or whatever, anything that was like really good or really bad, usually you would note. And then most of the aircraft, there was one person in the class who was in charge of that aircraft. And so you would give them your report as well. They would fly the aircraft once or twice, and then they would collect up all the other reports from everybody else who flew it. And then they would put together kind of an overall report of this particular aircraft.
Did you have any kinds of aircraft that were sort of your favorites for the qualitative evaluation flights?
That's really hard to say. I would have to say that I enjoyed every single qual flight I had. There was never one that I didn't enjoy. I would say, though, that probably the two that were the most memorable were a T2 flight that I took at Pax River because we did the high angle of attack, out of control. It was quite a ride. I mean, I've always enjoyed all of the spin training that we did, whether it was in gliders or A-37s. And the T2 was sort of the pinnacle of that just because it could do things that the other aircraft couldn't do. It could do Lamshabaks. I mean, it could do all kinds of maneuvers that I hadn't had the chance to see before. So that was a very enjoyable flight. The other one was the F-14. Even though you don't have a stick in the back seat, that was actually my qual airplane. That was the one that I had to, get the other people. And there was actually only 3 of us that flew it. We were all backseaters. 2 flight test engineers in the Wizzo in the class all flew in that aircraft. We went over to Point Mugu and got 2 flights. And that was very memorable, I think, just because it was such a different aircraft from the Air Force and kind of getting, I think, a better sense of what NFOs do versus Wizzos and how that whole crew coordination works between the Navy pilot and Rio versus the Air Force pilot and Wizzo kind of thing. So it was a very educational flight. I actually got 2 flights in that one too.
Oh, that's cool. Well, I was thinking through the flights that I got and what were some of the most memorable airplanes that I flew in. One of them was interesting. It was a Westinghouse-owned BAC-111, and it was being used as the airborne testbed for the B-1B's radar.
Oh, wow.
And so it was a really neat introduction to high-resolution ground mapping and synthetic aperture radars and all that. Very, very cool flight. Another one was the variable stability Learjet.
Oh, yeah. Mm-hmm.
I mean, this was an airplane that had a computer where you could basically configure the flight control system to do all sorts of interesting things. We think about the aircraft's stability control characteristics, and we think about, things like short period and phugoid and directional stability and all that. And what this flight showed me was that just the feel of the control stick had as big an influence on the flying qualities of the airplane, the forces on the control stick, how far you had to move it, as the airframe itself.
Yes. Mm-hmm.
And that was a neat lesson. And instead of just sort of academically telling that, I wasn't sitting in one of the seats, but I could just, reach over and grab the stick and everything. And that was very cool. 2 other really memorable flights. I got to fly in a couple Navy airplanes, the E-2C Hawkeye, which had an awesome capability, and the P-3C Orion. We went out over the Pacific Ocean. I was sitting back with the sonar people, and the chief said, well, do you want to see how a sonobuoy works? Yeah, sure. So we dropped one in the water. We're listening. This guy's a chief petty officer in the Navy. This is what he does for a living. And he says, I hear a ship. I'm listening, and I'm like, of course I'm going to be, I'm a guest and everything. So I don't want to go, stop yanking my chain. There's no ship out there. Well, he turns on the displays, and sure enough, you could see the signature of a propeller. It was very cool. So I sort of got to rotate around on that flight, and I got to use the sonar and the radar and the infrared, and I got to fly the airplane for a while, and it was great.
I remember the P3, because I did a similar kind of thing. And the thing I remember the most about the P3, though, was once we got out over the ocean and they shut an engine down to save fuel. I was like, what? You're doing what? I was quite amazed that they did that. I mean, I'd been on 130s. The 130 I flew on at Holloman was a bit old, and it seemed like we were shutting down an engine all the time, but that was an emergency, and these guys were deliberately shutting down an engine, and I remember that really got my attention.
So I've got a couple questions from Fighter Pilot Podcast supporters. The first one's from Jeevan Deva, and he said, I've read it's possible for civilians to apply to the Air Force Test Pilot School. What experience or skill set does TPS look for in civilian applicants, and what do they go on to do after completing TPS training?
The application process is pretty much identical to the military, so they're looking for the same thing. They're looking for a bachelor's degree in some engineering discipline or operations research, physics. There are numerous technical degrees that are acceptable, and I can't give you a laundry list of all those right now, but it is some kind of a technical degree. Typically, you need to have a fairly high GPA. I believe the minimum to even apply is a 3.2 GPA. And if you don't have that as an undergraduate, don't stress out yet, because you can go and get your master's degree, and that can help make up for a lower undergraduate GPA. Quite a few people do that. A master's degree certainly helps when you're applying. However, you do get a master's degree from the school now. You didn't when I went through, but you do get a master's from the school. So it's helpful, but definitely not a requirement. And as for engineers, obviously having some experience in flight testing is pretty much mandatory. A lot of military don't necessarily have flight test experience before they come to the school, but with the civilians, it's, I think, pretty much mandatory that they have at least some exposure to flight testing before they come to the school. Like I said, it's pretty much the same process. You put in your application, they'll invite you to come and interview. And then after you go through that process, then they'll make that final selection. That's a little different than when I went through before as well. It used to just be a board process for the engineers, but now you have to actually come and go through an interview process as well.
And the civilians are civil service engineers in the Air Force.
Yes, they're civil service, right. So this isn't just any civilian. This is civil service engineer. So you already have to be in civil service. Once you go through the school, you'll go back to some kind of flight test organization, just like the military graduates, and you'll do some kind of a flight test job, just like the military graduates. In many cases, you'll be continuing to fly. If you're at Edwards, they'll be working in some kind of a combined test force. If you're at Eglin, in a test squadron there, the jobs are quite similar. It's just that the civilians tend to stay in one place longer than the military. They're not necessarily expected to go off and go to the Pentagon and go to school at Air Command and Staff and all of those kinds of things like the military are.
Here's a question from Fighter Pilot Podcast supporter Jeremy Ray. Will graduates automatically be assigned to a test squadron upon graduation? And if not, will their home squadron, I guess meaning the squadron they came from, hold their place, or will it be filled and the graduate reassigned after they complete the course?
So this has changed over the years. So normally now, when you go to test pilot school as a civilian, your position then becomes open and they will fill that normally. So you normally will not go back to that position. Before you go to school or early on while you're at the school, though, they have what's called a graduate management council. That set of people should be trying to figure out what job you're going to be going to when you graduate. You will not be expected to find your own job. Now, that's changed over the years, because in the past, we did not do a very good job of managing our civilian test pilot school graduates. We're starting to do a better job of that, of making sure that they have a good assignment coming out of the school, and that we continue to track them throughout their career and manage their careers a little bit more hands-on than we have in the past.
So here's a question from Fighter Pilot Podcast supporter Sean Jones. How long does one stay a test pilot or test nav, or I guess now called a test CSO or flight test engineer in the military? For example, do you rotate to another unit after a few years, or do you stay at Edwards forever?
Typically, you'll rotate to another unit after a few years. Most people will get 2 test assignments, and then they'll go off and start doing other things. Typically, you'll get an assignment at, say, Edwards, if you stay at Edwards, and then perhaps you might move to, say, Holloman. And then perhaps at that point, you're ready to go off to school, to Air Command and Staff College, or perhaps go to a program office or up to the Pentagon to a staff job up there. And then people kind of go off in different directions after that. A lot of people do stay in testing. So even though they might go to a program office for a few years or go up to the air staff for a few years, they'll come back to testing. A lot of people kind of bounce back and forth. It just depends. We have some people that go through and do 1 or 2 tours in testing, and then they go back to being operational pilots. Jacqueline Van Ovost, who's the 4-star commander of Transcom now, went that route. She did a couple of test assignments, and then she went back to AETC and to AMC and moved up the chain through that side of the house instead. So the Vice Chief Staff of the Air Force also did a similar thing. He did a test tour and then kind of went back more on the operational side of things. So it's a variety, but I would say the vast majority of people do a couple tours, go do something else, and then kind of bounce back and forth after that.
You were a flight test engineer down at the F-16 Combined Task Force doing Leonard. What exactly was the testing like? What did you do down there? What was your particular role in it?
So at that time, the Lantern system had just come back from initial operational test and evaluation. There were some issues that had to be resolved before it could be fielded. They had made a bunch of modifications to the system and brought it back in for some additional development testing. So the system was pretty mature when I was working on it. We didn't have a lot of the growing pains that you have with a typical early system. So mostly what we were doing was doing some additional work with integrating it with Maverick missiles and with laser-guided bombs was most of the work that I was doing. We did a lot of testing out on the ranges where we would do simulated Maverick shots or simulated laser-guided bomb releases, using the navigation pod to get to the target, using the targeting pod to pick up the target and then hand it off to the actual weapon that was being dropped. We did very few actual drops, so mostly it was making sure that everything's working right. We went to Eglin Air Force Base for about 6 weeks to actually launch some Maverick missiles to make sure that that was all working okay. So the thing on Lantern was, and of course the thing on the F-16 is a lot of the aircraft are single seat. So in a lot of cases, I was not actually flying in a Lantern aircraft. In a lot of cases, I was doing, say, chase support. We didn't have a control room. So in a lot of cases, I was really just planning for the tests, making sure the targets are set up on the range, briefing the pilots before they go out and fly. They collect the data, they come back, and then playing back the videotapes and getting all the pilot comments and analyzing the data. Like you were saying, I did most of the writing of the actual reports. We get inputs from the pilots, but it really fell to me to do most of that test planning and then analyzing all the data and then writing the report.
What kind of problems did you find with Leonard?
Like I said, by the time I was working on it, we didn't have a whole lot of problems. There were a few issues left with some of the non-guided weapons releases that we were doing. I remember we were working through some issues with that. I do remember one thing, this is very typical of testing, is they were trying to update the software for the unguided weapons releases. They sent us a new software load from Fort Worth, put it in the aircraft, pilot goes out and flies, bombs all miss their targets, right? So they come back and, well, what happened? So they look at all the data. Well, it turned out there was a number that was put into the software wrong. And they go, oh, we'll send you another tape, right? Another software load. So they send us another software load. This one's got the number right. So they go out and they fly again. All the bombs miss the target again. So we go, oh, now what happened? So they look at it and they go, oh, well, the number's right, but we put the wrong sign on it. So now they have to send us a third tape. So now we're 3 weeks into this whole thing, just to get one number right, and it's finally working right. Those are kind of the typical kinds of problems that you encounter. Sometimes no matter how much you check something out on the ground, you're not going to know until you actually get in the airplane and actually have all of the dynamics involved and everything that it's not what you thought it was.
Yeah, there are definitely things that really only come out in the dynamic flight environment.
Yeah.
I've got 2 stories like that also. The first it was before I arrived at Edwards, but they had the new offensive avionics system on the B-52. They were retrofitting with the digital system. And for the first time, I forgot whether they were taking a 3-ship. It was already deployed with Strategic Air Command. I forgot whether it was the first time they crossed the equator or the first time they crossed the international date line. It was one of the two. There was a defect in the calculation. So when you crossed one of those, you got a divide by 0 or something like that in the navigation. And so the first airplane crossed the line and they reported back, hey, we just lost our navigation system. And then the second airplane crossed the line, yep, we just lost ours. And then the third of the 3 ship was, we just lost ours. needless to say, that was marked down as something that needed to be tested in the future.
Yeah. Yeah.
It was something like a divide by zero. They took a cosine or a sine or whatever it was at the angle and did it. Another thing is we launched a test missile once off of a B-52. The missile just went sort of, it had a mind of its own. Eventually it had to be terminated. What we found out was that there was a magnetometer on the missile to measure its heading. The calibration constants hadn't been loaded for that. And so the missile just didn't know which way it was pointed.
Yeah. Yeah.
So, these little things can have big, big consequences with computers.
I remember at Holloman one time we had a test failed. You have your magnetic variation, which is plus or minus depending on where you are. And in some parts of the country, it's very large. And New Mexico is one of those places where it's very large. And somebody entered, and I can't remember if it was plus or minus, but they entered the wrong direction. They had the right number, but again, they had the wrong sign. The test, failed just because somebody entered that wrong sign. So yeah, very easy mistake to make.
With your lantern testing, and you might have been intimately involved with this, there was at one of the Edwards flight test safety meetings, there was a video, and it was a F-16 with a lantern pod doing a low level, I think, on the way up to China Lake, and they just barely missed us, like a Cessna flying low. And so you're looking at the video. You may remember this far better than I do, but you're looking at this video, and you can see an F-16 bopping along at high speed and low altitude, and all of a sudden, zoom! And there's this Cessna that fills the screen and then disappears.
Yeah.
Do you remember that?
I was not there when that actually happened, but that was a very popular video, as you can imagine. I did know the pilot who was in the aircraft at that time. I can't remember who was in the back seat. It was not a normal, it was like an incentive ride or something like that. It was not a normal test mission, where you've got, like, say, a flight test engineer or another pilot in the back seat. And I don't know if you remember when you watch that video, the Cessna goes by and then it's like 4 or 5 seconds before the pilot finally says, "Did you see that guy go by?"
Oh, yeah.
It took him that long. He said he was so scared that it took him that long just to get his voice back because he was in such shock that they had almost hit this guy and he couldn't even say anything. And I remember having that experience once on the range where I was in a 2-ship F4s and we were in the lead. We were climbing out. It was kind of one of those rare hazy days. They called some traffic out about 5 miles away, and I'm doing my checklist and everything. I'm looking, I can't see. And so I'd finished my checklist. I remember I looked back out, I was thinking, now where did that guy go? And all of a sudden I see this blob going underneath the F4. And I was like, and it was the same thing. It was like I couldn't even talk right away. It was like, there's somebody going underneath us. I finally managed to get it out. And anyway, as I was doing all that, I looked over at our wingman. Our wingman was just pulling away, like crazy. But yeah, just every once in a while, you see something like that. It leaves you speechless. Yeah.
Now, you ended up as a test squadron commander.
Yes.
Out at Holloman. What was the path from being a flight test engineer in a combined test force to being a test squadron commander?
I bounced around a little bit. I was actually back on the staff at Test Pilot School for a couple of years. That was very interesting. From there, went to the C-17 program office at Wright-Patt. Did that for a couple of years, came back to Edwards, was there in the CTF, still assigned to the SPO, but working in the CTF. Did that for a year and then got picked up to go to Air Command and Staff College.
Before we go on to that, could you just explain what you did in a program office with the C-17 as opposed to being out at Edwards?
So I was still doing testing in the program office. So what I was doing was more looking at the whole test program and figuring out, okay, what are all the resources that we need to do the testing? How much money is it going to cost? How many people? Getting the funding, sent out to the test center that they needed, their flight test center at that time, getting them all of the money and the resources and everything that they needed to do. Working with the Army a lot, actually, because the Army was very heavily involved in the test of the C-17 from an airdrop perspective. So spent a lot of time coordinating with the Army and making sure that their test requirements were being made. I wasn't directly in charge of putting together the test and evaluation master plan. That was somebody else in my office, but that's kind of the level that you're working at the program office. I was also in charge of pulling together all of the detailed test plans before the first flight. because there was no combined task force at the time that was very small when I first got there. So we didn't have an army of engineers at that time to go and sit down with the contractor and make sure that we got a good detailed review of all of those test plans. That was one of the things my bosses wanted to do, was to make sure that we at least had a 90% solution on, what we were going to do with the whole test program, and really understood what all the test points were that we were trying to collect. So I spent a lot of time every month going to meetings and going through every single one of the test plans with a fine-tooth comb, again, making sure that it wasn't just the Air Force needs that got met, but also the Army and the Marines, because Marines had some input into all that as well. It was a very interesting job. I learned a lot because prior to that, I had just been involved in like one part of an airplane test. And now I was looking at the whole airplane, everything that had to be tested on the airplane. I learned more about wheels and brakes and environmental control systems and all kinds of things that, I wouldn't have probably known anything about if I hadn't had the opportunity to do that.
That's neat. And you were there through the first flight of the sequence thing?
Yeah, so I got back out to Edwards in, I think it was August of 91. First flight happened in September, and I was sitting in the control room at Edwards during the first flight. The aircraft took off from Long Beach and flew up to Edwards. I think it was a little over 2-hour flight, landed at Edwards on a Sunday afternoon. That was one of those things when I was involved in it, I didn't really think that much of it. I was just doing my job, right? And it wasn't until many years later, looking back on that I realized what a great opportunity it was there to be involved in the first flight of an aircraft like that, a clean sheet design like that.
There are not too many opportunities.
No, there's
There used
not.
to be in the 50s, there were a lot of those, but today, not so many. Or even 30 years ago, there weren't that many.
No, but it was interesting because the B-2, I think, had its first flight like in 89, if I remember right. Yeah. And then you had the C-17, just a couple of years later. And then, so we did have kind of a little spurt of activity there in the late 80s and early 90s. Yeah. But yeah, now we get a first flight at Edwards every 5 years, maybe.
Right. Well, you also had the 2 advanced tactical fighter
Yes.
Prototypes at the same time.
Those were going on as well. So yeah.
There was definitely a spurt of that stuff, of new aircraft first flights, which is quite rare.
Yeah.
Then you went to Air Command and Staff.
Yeah, and from there, I was convinced myself I was coming back to flight testing because I really didn't want to go to Air Command and Staff College. I was like, wait, can't I wait a couple more years? I just got back to Edwards. I want to go do some other stuff. But I went to Air Command and Staff. And then from there, I went up to the Pentagon, which was not something I had envisioned for myself. But I spent 2 years there. I was working in Air Force Studies and Analysis Agency, which is now called A9. I think they've actually just reorganized and they're calling themselves something else again. I did a lot of work with air-to-air missiles and studying air-to-air missiles. It was really very, very interesting job. And while I was there, one of my test pilot school classmates was a squadron commander at Holloman. He was a little bit older than me, and he was in the flight test squadron there at Holloman. I ran into him, I think, at the Society of Experimental Test Pilots. They have a symposium every year. And he asked me to send him a resume, and I did, and he handed it off to the group commander. And the next thing I knew, I was getting a call from the group commander, giving me an interview and then offering me a job. And I was like, oh my gosh, I'm still not sure how that happened. Yeah.
Were you the first woman to command an Air Force test squadron?
I think so. I don't have any evidence that anybody else did it before me. So now it was a test squadron. It was not a flight test squadron.
Which squadron was it and what did it do?
So the first squadron I commanded was the 846 Test Squadron, and they operate the Holloman high-speed test track. I did that for about 9 or 10 months, and then we had the 746 Test Squadron commander left, and they moved me over into that squadron, which surprised me. I was quite honored to get to go back into the 746, which was the navigation test squadron, which is where I had been when I was a lieutenant. So that was kind of fun to be able to go back and command a squadron that it wasn't a squadron when I was there before, it was a division. So, but it was fun to be able to go back and command the squadron that I was in as a lieutenant.
What is the Holloman high-speed test track and what does it do?
So it's 50,000 feet long, 10-mile track. It's got 3 rails on it. Think of it kind of like a train. It's not train rail, it's actually crane rail, but it's similar. It looks a lot like a railroad track, and it's very straight. You can mount a sled on it, and then you put some kind of an article that you're trying to test on the sled. It was originally doing a lot of ejection seat testing. You can do missile testing. We did a lot of warhead testing when I was there. Warhead for a lot of Navy missiles, that sort of thing.
So where you put the warhead on the sled and detonate it?
So you accelerate the sled. You don't detonate it on the sled. You launch it off of the sled. And then the warhead goes into a target. You're looking to see how it destroys the target or doesn't destroy the target. So, and some of these tests are very fast. When I was there, we pretty routinely did tests that got up to Mach 6.
On a track?
On a track, yes.
Now, why would you use a track instead of launching it off of an airplane?
First of all, it's a lot cheaper because you don't have to have the whole missile on there. So you're generally accelerating these sleds with surplus missiles with motors that are not necessarily flight qualified. You can save a lot of money. Plus, it's a much more controlled environment. It's very precise. If all you're trying to do is test the warhead, you really don't need to have an entire aircraft, launch it off of an aircraft if all you're trying to do is collect data on the warhead itself.
How many sled tests a year did you run?
It varied. The high-speed ones, we could maybe do 10 a year, and then you have all your ejection seat testing and in between. I mean, it varies a lot on the kind of tests that you're doing. So it could easily be 20 or 30 tests, even more if you're doing some stuff that doesn't require a lot of buildup.
And then you went back to the navigation test where you commanded that squadron.
Right. And by that time, it was mostly GPS testing. They were not doing that much inertial testing anymore because GPS that was in 96 when I got there. And so that was after the first Persian Gulf War when the military finally figured out that GPS really worked. Maybe they wanted to use it. So, and at that time, I think just as I got to the squadron was when the last satellite went up to make it a fully operational constellation early on. Obviously, I think that constellation's all been replaced by now, but so it was still fairly early in the GPS program.
I have a question about GPS testing. Back in the 80s, when we had inertial navigation systems on bombers, the way that we used a reference is we had this system called Cyrus, which I think came out of...
It came from Holloman, yes.
And it was a reference system that used ground-based transponders. And so you could compare the system on the airplane to this reference system, and you could come up with an error. Now, with GPS, which is excruciatingly accurate, what's the reference system when you're flight testing GPS?
Some of it is you can use, a Kalman filter to combine all sorts of inputs and come up with something that's very accurate. Typically, that's going to be a system, though, that you can't use operationally because it's going to require something like those ground-based transponders like you were talking about. So the other thing you can do is they do still use what's called Cine Theodolites, which is basically an optical system, which is extremely accurate. But that is one of the things that we were dealing with when I was the squadron commander there, was coming up with instrumentation that could get you down to feet of accuracy. It used to be with an inertial navigation system, your inertial navigation system might be accurate to maybe a quarter of a mile if you're lucky, so you didn't have to worry about having something that was super, super accurate. And now you're testing systems that are accurate to 50 feet or 100 feet. And so now you've got to have your reference system be accurate to like 5 feet. There's all kinds of techniques that you can use to get that accurate. You have like differential GPS and some things nowadays that are more common, but back in the 90s, we were still coming up with all of those ways to do things.
You used a couple of terms here that some of our listeners might not be familiar with. One of them was Kalman filter and the other was differential GPS. Could you explain those a little bit?
Just think of a Kalman filter as just taking lots of different pieces of information and combining them in a way that you get a better answer than any of the individual pieces of information. It's based on a lot of statistical theory. I'm not going to try to describe it all, but basically different information sources are accurate in different domains. So tell me if I'm getting too technical here. So the example that I always use is an inertial system. It drifts, but when you tell an inertial system, this is where you are, 5 seconds later, it still knows exactly where it is. 30 seconds later, it still knows pretty much exactly where it is. It's only after 30 minutes or so that it really starts to drift off. So in the short term, an inertial system is very, very accurate. If it knows exactly where it is, it's not going to suddenly drift very quickly in the short term. On the other hand, you take a radio navigation system, it could have one measurement that's just totally wild, right? You could get some atmospheric interference, or maybe the transponder on the ground hiccups and gives you a bad signal. And all of a sudden you have this huge error, right? But if you take that system and you just sit there and you take 30, 40 measurements from that system, those errors will average out. And so one measurement from that system might be wildly in error. But over time, in the long range, they're going to all average out and you're going to have a more accurate system. So now you have two types of navigation, one that's very accurate in the long run and one that's very accurate in the short run. You combine those together, now you are able to get an answer that is more accurate than either one of those systems can give you by itself.
What about differential GPS?
Differential GPS, that really is just taking two different signals. I don't want to say it's the same idea because they're both GPS, but it's that same idea that you have two different receivers and you're now able to combine those two pieces of information in such a way that it becomes more accurate than just with the single signal.
One kind of differential GPS that I'm familiar with is if you have a receiver on the ground at a known position and you receive the signals from the satellite, there may be a slight error between where it calculates it is based on the signals from space and where you know you are because you're bolted to the ground. So there's a little bit of an error there. You can then broadcast that error up to the aircraft. And if an aircraft is flying near the ground-based thing, you've got that little correction and the aircraft can incorporate that in. That's one kind of differential. That's called a local area.
There's lots of different ways that it's mechanized. So yeah.
Now, here's a question from Fighter Pilot Podcast supporter Jim. It's sort of a broader question. Why does flight testing take so long these days? In the 1950s, Edwards was testing out new jets and platforms monthly, weekly. You know, there was the Century series, and they were sort of banging out one of those a year. Now it takes 20 plus years to develop a new fighter like the F-35. Why does it take so long?
It's not so much that the testing takes longer, it's the development takes longer. The systems are much more complex. F-100s didn't have any software on them. And the development timelines have really stretched things out. What we find is that, you know, when a system arrives for flight testing, if it doesn't have a lot of problems, it can go through a test program pretty quickly. And we do see systems that show up, not necessarily entire aircraft, but we do see systems that show up that go through their programs very quickly because they don't have a lot of problems. But typically, the more complicated your system is, the more problems you're likely to run into early in the process, and that's going to slow you down. So that's typically what the problem is. It's not that the testing takes longer, it's the development takes longer. And every time you find a major problem in a flight test program, not all, but in some cases, it can shut down your program for quite a while they figure out a fix.
Speaking now, and I'm in the aerospace industry now, I've seen two things that really stretch things out. The first is that the requirements for documentation and data submissions are vastly higher than they used to be. I mean, in some cases, what's called the contract data requirements list is satisfying that is almost like another development program. And that's one thing. Another thing that I've noticed, we're far more risk averse than, say, we were back in the 1950s. You know, it used to be that you'd have, in fact, airplanes used to crash a lot back then.
Yeah.
But now, if you have a problem, it used to be you'd implement a quick fix and you'd go back up in the air. Now, between finding a problem, figuring out what you're going to do, implementing a fix, getting everybody to sign off on it, and coming back could be a year more. And that really stretches things out. So, and I think those are two of the things that are also stretching things out. Why say an F-35 takes much longer than an F-100 did.
Yeah, no, and I would agree. I think our planning processes are longer now because we got tired of losing airplanes, quite frankly. You know, that was another thing. Like you mentioned, back in the 50s and 60s, we lost a lot of airplanes. And it was in the 70s that we started changing some of our planning processes to account for safety risks more. But it does take longer. You're right.
One of the things that surely has changed is the safety factor. I mean, if you look at like the Century series in the 1950s. I mean, experimental airplanes were just crashing left, right, and center. And yet,
it was a very dangerous time to be a test pilot back in those days. Yeah.
whereas if you look at, say, like the F-15 flight test program, they didn't lose any airplanes during that program.
No, neither did the F-16.
Neither did the F-16, and that's a huge change. Our abilities to do computation, simulation, and modeling are vastly better, so we can crash airplanes on computers instead of crashing them out on the dry lake bed.
Yes, definitely.
And I think our risk management's a lot better than it was back then, too.
Mm-hmm.
What did you do after your squadron commands?
I actually went down to Eglin for a year. I was what's called the Commander's Action Group Chief, which was a very interesting job working for the 2-star, doing a lot of briefing preparation for him, speeches, that sort of thing. It was really interesting to work directly for a 2-star at that point. I was lieutenant colonel and, kind of get a better idea about how general officers think. And then from there, I went to ICAF, which is now called Eisenhower School. It's a war college up in the DC area. From there, I pretty much got into mostly staff assignments. I was back at the Pentagon. I did a bunch of work with modeling and simulation. I did wind up doing another test assignment, but not in development test. I was a joint test and evaluation director down in Suffolk, Virginia. And we were looking at how do you test systems in a joint environment, so a much more complex environment than just, say, a single aircraft on a single range. Did that for a while. And then I retired as a colonel in 2010.
And what have you been doing since then?
So I actually came back as a government civilian. That was not really my plan, but I kind of fell into a modeling and simulation job as a senior executive at the Pentagon, a technical executive. Did that for about a year, and then there's a senior executive, senior level technical job at the test center, and that came open in 2011. I was able to move out to that job, so really got back into flight testing with that job. Left government service in 2013 for about a year. I wanted to go do some other things and then came back in as a senior executive. Did a whole bunch of jobs in there before winding up back at Edwards again in 2019.
Looking ahead to Air Force flight tests, and you've gotten, I would say, the grand tour of Air Force flight test over the last 40 years.
Yes.
But looking ahead, what's coming and what are the changes that are coming? I had some thoughts that I sketched down here, but I'm curious of your thoughts.
Well, I looked at what you wrote, and I think it's pretty much the same. I think there's going to be a lot more testing of hypersonic systems, and there's obviously a lot of challenges with that in terms of range, space, instrumentation, all kinds of challenges. But we're also starting to, see more and more autonomous systems, having to test systems with artificial intelligence, systems that learn, autonomous systems that, you've got like your wingman, your loyal wingman, that kind of, think of it as kind of an R2-D2 that's flying with you. So a lot of these systems have a lot of challenges associated with them in terms of safety, planning, airspace. If you have a system that's learning, how do you know when it's actually working right? So there's all kinds of challenges involved in these various systems. So I see a lot of that as the future. We're also getting a lot more into space testing, not us at the test center itself, but working a lot with Space Command, figuring out ways to do better testing in space itself.
Question about hypersonics. 60 years ago, Edwards was testing the X-15, which was definitely a hypersonic aircraft. How much of that is relevant to what we're doing today?
Well, I think it's all still relevant. The idea that you're lifting something with a carrier aircraft and taking it out and then launching it. I mean, I think a lot of the profiles that we flew back in those days, they may not be the same profiles, but a lot of the thinking and the planning that went into all of that, I think is all still very relevant to today. There were people at Edwards up until probably about 8 or 10 years ago that had been involved in a lot of those early programs, and they still had all of that knowledge, and they were able to transfer that knowledge, to a younger generation. Everything you learn in testing, I think, is valuable. And that, I think, is one of the biggest problems that we have is capturing that knowledge and keeping all of that knowledge. Because sometimes things do go into testing for a while, that maybe the technology is not quite ready. And so the system goes away. And then 10 or 15 years later, the technology matures. But all the people who worked on that original system have gone off to do other things, and you've lost that knowledge. And that, I think, is one of our biggest challenges, is capturing that knowledge so that we can reapply it. because the older stuff a lot of times does have a lot of relevance to the newer things that we're testing.
I think the next sort of big new aircraft coming to Edwards is going to be the B-21.
Yes.
And that's very classified. And obviously in this forum, we can't probe on anything classified. But on an unclassified level, what are some of the challenges that we're going to have with flight testing the B-21?
I really can't say because I just haven't been involved that much with the program. I would guess that testing the B-21 is probably going to be very similar to testing the B-2, but I was never involved in that program. So I'll be the first to admit I don't really know that much about testing bomber aircraft. That's the one shortfall, I guess you could say, I have in all of my test experiences with actual bomber aircraft.
Over the course of your career, what have been the biggest changes in flight testing?
Probably the biggest change is from, kind of a paper-based approach to digital systems. Almost nothing is done on paper anymore. When I was young, we still used calculators. People carried calculators around. Nobody had spreadsheets. Nobody had a personal computer. All of that started coming online as I was, going through test pilot school. But the computers were not very powerful. We mostly just used them as word processors. And if we wanted to do any analysis, we typically had to write our own programs, to do analysis. And also all the strip charts, everything was all paper-based. You didn't sit and monitor a screen in a control room. You monitored a strip chart and you could write things on it. And all the test plans, at that point we were starting to put things onto word processors, but everything still got printed out. All the test cards, everything was all very much paper-based and things got lost a lot. I think we have issues with going digital, but, in terms of okay, I've got something on a floppy disk that I can't read anymore, right? In terms of format and stuff like that. But I think it does make it easier to archive information and to be able to go back and get that information at a later date. So I would say that's the paper and then going from analog systems to digital systems. So everything now is digital. Even though I think it causes some problems, it also, I think, is just the amount of information that we can collect now, the amount of data that we can collect and analyze is just so much more. Used to be you were limited to a handful of parameters on a test. Every parameter you wanted to collect had to fight its way onto a test card, and into the instrumentation system. And that now you can collect just about anything you want. Sometimes it can be a little bit overwhelming, but at the same time, it opens up all kinds of possibilities for us to be able to evaluate systems in ways that we could never have imagined doing 40 years ago.
When I entered the aerospace industry in 1989, after I left active duty, we had blueprint cribs.
Yeah.
And you would have the drawings of the aircraft on pieces of paper.
Mm-hmm.
Now, of course, it's all in product lifecycle management. It's three-dimensional models and drawings and product lifecycle management. So that's a pretty dramatic change.
Yeah, and just the accuracy that you can get now, with all of the CAD CAM. A lot of times you had to build prototypes and mock-ups because you didn't know if things were going to fit together, right? And now you do all that on the computer, and the first time it rolls off the assembly line, it works perfectly.
Yeah, it fits together.
It fits together, yeah. I remember hearing about, and this may not be a true story, but I remember hearing a story about Boeing. The 777 was the first aircraft that they designed completely with CAD-CAM, CATIA, the whole 9 yards. And the story I heard was that when they went to close the passenger door, where everybody walks onto the aircraft, when they went to close the passenger door for the first time, it closed. And that had never happened before.
Oh, wow.
Every other aircraft, for the first time they tried to close that door, something was misaligned, something wasn't quite right. And that was, doing it on the computer, though, took out all of those inaccuracies.
Well, it'll be interesting to see how, over the next generation, how things change as we get hypersonics and autonomy and things like that. It's going to be a pretty exciting time, I think.
No, it's a very exciting time to be in testing, I think. And modeling and simulation is another thing that has changed so much the way we do things. I don't know if you remember, back in the 80s, going to the simulator was like torture, right? The simulators were so bad, and now there's things you can do in the simulator that you can't do in the real airplane. The simulators are so realistic that in many cases, as long as the models are validated, you can collect information, you can do things in the simulators that are actually better than something that you can do on a range. That's how far we've come.
When I was an undergraduate between 1981 and 1985, when we were doing control work, we were using pencils and calculators and things. When I went to graduate school, which was between 1992 and 1995, so basically a decade later, it was all on computer. We were using MATLAB. we could run the most amazing simulations, and we could do vastly better stuff, orders of magnitude better in a tenth or a hundredth of the time.
Yeah.
It was really dramatic.
Yeah.
That certainly is a change, and it hasn't stopped since then. So outside of work, you've also written some interesting books. Perhaps you could tell us about those books, which I've read both of and are both great, and one of which is one of my very favorite books in the world. So please tell me about your books that you've written.
My first book was The Propeller Under the Bed, subtitled A Personal History of Home-Built Aircraft. It started out as just a book about my dad. He designed an airplane when he was in college to set an aviation world record, so a nonstop distance record for an aircraft that weighed less than 500 kilograms. So 1,102 pounds. It was his senior design project, and his intent was to actually build this airplane and go set the record, within a few years after he got his degree. But he was in the Air Force at the time and, deploying and doing all kinds of things and family, kids, all that kind of stuff. He just, didn't get around to it. And so finally, after he retired from Boeing in the 90s, he built the airplane. He finally set the world record in 2010 when he was 82 years old. So it started out as just kind of this story of perseverance. But as I was writing it, I realized that all of these other things had happened in the home-built aviation community over that same time period, that 50 years that it took him to finally get this done. And I actually wound up going back a little bit further into the 20s and 30s with home-built aircraft as well, and wove the two stories together. And it's not really a history just of home-built aircraft. There's also a lot of history of general aviation aircraft in there as well, all the way up through the X Prize, which was actually won by a home-built aircraft designer, Burt Rutan. It was a really interesting book to write and research, and got a lot of really interesting stories from my dad that I hadn't known about, a lot of crazy things he did in his youth. You always think of your parents as these old people, and you forget that they were young once too and did crazy things.
What I loved about this book was that, first of all, I love general aviation and home builds and things like that, but how you weave this together with this just fantastic story about your dad and his 50-year quest.
Yeah.
And an 80-something-year-old man finally doing it after 50 years. And I just thought it was just a great human story. And of course, with your technical background, you kind of explain what the challenges are of building this airplane and testing it. It's a wonderful book.
Oh, thanks. Yeah. It was a lot of fun to write. So yeah.
And then your second book was on military aviation.
Yes. So I'd done some freelance writing. In fact, before I wrote the first book, I had done some freelance writing to kind of get my foot in the door and make myself a little bit more credible to a publisher. And I had been writing some articles for Air and Space magazine. One of them was on the F-8. I really didn't know much about the F-8, but they had asked me if I was interested in writing it. I'd written an article about the F-16 at that point that was a very popular article. So I was, doing all my research and interviewing people for this story on the F-8, and I tripped over a YouTube video about a guy who had got hit over North Vietnam and ejected into the Gulf of Tonkin. And there's not an actual video of him doing that. Obviously, there was not video back in those days. But the ship, one of the ships involved in the rescue, had recorded all of the radio transmissions during the rescue. So this video had pictures of him and some of the radio transmissions and everything. I thought, wow, this is a pretty interesting story. And I thought it would be another article. And so I was able to chase the guy down, and he was happy to talk to me. And so I started writing this article, and it just kept getting longer and longer and longer. And pretty soon I realized that I had a whole book on my hands, because I didn't want to just write about the rescue. I wanted to write about all these people that did the rescue, and what was their role, and how did all those airplanes wind up there to rescue him in the first place, And that just kept, kind of like with the first book, it kept leading me to all this history of combat search and rescue and how that all evolved from World War II all the way up through the Vietnam War. And again, wound up weaving these two stories together. And it's also not just about rescuing one individual. It's about not leaving people behind. So even after the war is over, making sure that we make people whole again, whether that's physical injuries or psychological injuries, and also continuing to look for people who are still missing. So bringing all of those pieces together. I suppose I should mention the name of the book.
Yes, I was about to ask you.
Yeah, I should have mentioned that up front. So yeah, it's Unforgotten in the Gulf of Tonkin. And now I can't remember the subtitle. So the Unforgotten in the Gulf of Tonkin, a story. Oh no, I can't remember it. So
Oh, I don't
put me on
remember
the
it
spot
either,
here.
but I'll tell you, it's another great book.
Yeah.
I very much enjoyed reading it. Again, I liked how you weave different threads together. Not only the narrative of this particular really interesting rescue operation, but also kind of the history of Air Force and military combat search and rescue.
Yeah, and then again, that was one that was just really interesting to learn all of that because I didn't know any of this when I first started. I always just kind of assumed combat search and rescue was there, and I didn't really know how it had all evolved over the years. It was all very interesting to learn.
Where are you going from here, both professionally in terms of your flying, in terms of your writing? What's next for you?
I really don't know in terms of professional. I'm getting close to retirement from my professional side on the government military side of the house. I can't say exactly when that's going to happen, but it's probably within the next few years. On the writing side, I am working on another project right now. It's tentatively titled The Fly Girls Revolt. It's the story of the women who kicked open the door to flying combat in 1993. Mostly focused on the women aviators of like the 70s and 80s time frame who started flying in the military back then, flew in Desert Storm, and then were the ones that were there when they finally decided to allow women to start flying in combat aircraft and flying on Navy ships. So there's a little bit more history in there too, back in World War II, with the WASP and some other things that happened. But the focus is the women of the 70s and 80s.
Interesting. What about flying? What are you going to be looking forward to doing in flying?
Well, I think I'll probably just keep flying my decathlon for a while. I do have this fantasy that I'm going to build an RV-8 one of these days. I have a tail kit. I haven't actually got much of it put together yet, so that's rapidly becoming a retirement project. But I really would like to build an airplane, at least part of an airplane someday. I've built a lot of parts, and you see I've done a little bit of work on my own airplane, but I really would like to be able to put a kit together and be able to fly that at some point.
Me too. My best friend from high school is a pilot for United Airlines. We meet every summer at Oshkosh, and we have ambitions of building an RV-14.
Yeah. I hope I get there. So, it may be one of those things that I abandon at some point, but that really would be one of my lifelong, I wouldn't say lifelong dreams. That was something that became a dream probably about 30 years ago, building my own airplane, but it's definitely a long-term dream that I've had.
The parting question on all Fighter Pilot podcast interviews is, do you have a personal call sign? And if so, how'd you get it?
I do. It's probably fairly obvious from my name. It's BJ.
Okay. So it comes from your name.
Yeah, it just came from my name.
That's cool. Because I remember it in Edwards at the 80s, call signs, maybe the fighter people had them, but the bomber people certainly didn't have them, and most engineers didn't have them.
I would say they were not as ubiquitous as they are now. My classmates and I all had Friday name tags that had our call signs on them. And if somebody didn't have a call sign, I think we gave them one. I showed up with mine, obviously. People just started calling me that somewhere along the lines. And so when somebody said, "What's your call sign?" I said, "BJ," so, yeah. It just stuck. So, yeah.
Well, thank you so much for being generous with your time and expertise. This was really fascinating.
Well, thanks. You've brought back a lot of good memories. So I always enjoy talking about Edwards. We've only scratched the surface, as you can imagine.
Are you going to be at Oshkosh this summer?
I will. I'm planning to be there. So I don't know the exact dates yet, but I am planning to be there at least part of the week and maybe the whole week, depending on how things work out.
I'll see you there this summer.
Sounds good.
All right. Awesome. Thanks again, Ken. And thank you, Eileen. I'm sorry I didn't get to do that interview because I always feel like I get to know the people when I do. And I'll still send her a thank you card on your behalf, Ken, because we still do that here. We're old fashioned, but man, what a career, what a wealth of experience she has.
Yeah, she really is someone who has just a phenomenal background in Air Force flight test, stretching over 40 years.
That's great. Hey, and you've got this host thing down. At least you're definitely improving, because when you started talking about AFIT at the beginning, I said, I wonder what that is. And then sure enough, you circled back and helped us understand. And so I thought you did a nice job with the acronyms and hosting, keeping the conversation going.
With the military and aerospace and acronyms, it's just out of control. We joke about it at work. And then in my book on the B1, I tried to put every single acronym, and I think it's like 7 or 8 pages of them. It's ridiculous.
Yeah. In the glossary at the end?
Yes.
Okay. Now, I forgot the name of the bar she mentioned, but is that the one that was depicted in The Right Stuff that they go to and hang out and then it burned down at some point?
Yeah, that's exactly it. It's Pancho Barnes.
Pancho Barnes. Okay.
And her Happy Bottom Riding Club.
Well, I have to say, Eileen felt to me like she fits right in the fighter pilot community because it's good to see you guys in the engineer world. You also party like rock stars. I mean, she mentioned drinking and carousing a few times there, it felt like.
Well, here's the thing about Edwards. I mean, it was and is a great place. I remember the first time I drove up there, I was a 22-year-old second lieutenant. I wasn't going to go to flight school because of my thick glasses. And I had learned that, hey, I could go out to Edwards and fly in military aircraft anyway and do some cool engineering. And I said, I'm there. I got this assignment. It was like my dream assignment. And I got it. I'm driving through the gate and it says, you're in the middle of the desert. And it says, welcome to Edwards Air Force Base, home of the Air Force Flight Test Center. And then you drive another dozen miles to actually get to the security checkpoint. I mean, it was like, my God. Everything I've been reading about in Aviation Week and building model airplanes, and it's all here. Just the coolest place. But here's the deal. If you're a single guy, it's not necessarily the best place in the world. This would never be confused with San Diego.
Yeah.
And my story is that once got me into a very serious situation in an airplane because I had a date with a young lady down in LA. You can drive down. It was like an hour and a half or whatever it was, drive down to LA or 2 hours or whatever it was from the base. And you could do that. But some ordinary schmo would drive down. I said, I'll meet you at Santa Monica Airport. I'm going to fly down. I'm up at Edwards and I ooze aviation coolness. So I get in a little Piper Tomahawk and I fly down. I'm going to meet her on the date. And here's the problem. There was this thick marine layer over the LA basin. You've got the pass there where California 14 coming down from the Antelope Valley opens up into the San Fernando Valley. And so I'm screaming down there with my hair on fire, at 115 knots in a Piper Tomahawk. And there's this low ceiling. And I go, oh, wow, that looks low. Well, I could better get a little lower. I'm kind of not using my brain necessarily, not making the best aeronautical decisions. And I go, oh, wow, that doesn't look good. I better get a little lower. And then I go, oh, bad word. This is not good. And I took a look around and I said, I can't do a 180 because there's rocks on one side and rocks on the other side. And I said, I don't feel like hitting the rock. So I said, clouds are soft, rocks are hard. And I just did a climb up through the marine layer, but I wasn't on an IFR clearance. In fact, I didn't have an instrument rating at the time, but I know how to hold a heading and pitch up. So I climbed. I had to do illegal, but better than hitting the rocks. And that was because Edwards Air Force Base was not the best social environment. And remember, we didn't have cell phones, so if I didn't go to Santa Monica, I was going to stand her up. So that's kind of my little aviation story related to the social environment.
I see.
But it was a very cool place to be.
I bet it was. But now you've got us all entrenched in this story with you. You have to give us the ending. Did you land somewhere else and call and profusely apologize, or was that the last date?
No. I popped up out of the marine layer because the tops are pretty low. Right. So I pop out, and meanwhile I was still talking to approach. I kept flying over the clouds towards Santa Monica, and there were some holes, and I got down into Santa Monica. I was there. It was a lousy date. I didn't particularly like her. But at least I didn't hit the mountain.
No, of course.
Is what I was trying to avoid doing.
Yeah. Well, this would be a lot less fun if you had hit the mountain back then. I'd be sounding pretty strange right now, talking to nobody. Well, we're glad to have you, Ken. All right. Getting back to Eileen and your guys' great discussion. I did look it up for you guys. The rest of the Unforgotten in the Gulf of Tonkin book title is A Story of the U.S. Military's Commitment to Leave No One Behind. And I'm just thinking here, Ken, you and Eileen are both authors, and I'm sure other flight test engineers are as well. What is it about that community that makes you such good writers, or it's just because it's part of your job for so long?
I actually think that you have to be a good writer to be a good flight test engineer because you spend a lot of time writing plans and you spend a lot of time writing reports and things like that. And good communication skills are just absolutely essential to the job. And since, we almost all have a love of aircraft and flying, it just goes together.
Well, might I submit that good communication skills are important to a lot of jobs?
Yes.
And most of us, frankly, suck at a lot of it. Even marriages require good communications. But
it's a work in progress at this end.
All right, moving on. Anything else on today's discussion on U.S. Air Force flight test engineers? I really enjoyed learning all about it.
People get this idea from the movies that a test pilot gets into an airplane and, as the cliche goes, pushes the envelope. And that's actually part of it. But I think that if you think that's what flight testing is, and that's all you think that it is, you really don't understand the picture, that this is a big team effort.
Oh, yeah.
We talked about flight test engineers, and certainly we're a critical part of that. But there's some people we also didn't bring up. For example, you have the whole instrumentation side of the business because aircraft have to collect data. So you've got engineers and technicians who are doing that. You've got the whole range side of the operation. Those are the people who operate the radars and the tracking optics and the telemetry receivers and the mission control center. And of course, you got the maintainers on the aircraft.
Mm-hmm.
You reach back and you've got all the engineers and other people in the program office. You've got the program managers. You've got the people at the aircraft or systems manufacturers. It's a huge team that has to work together. And it's actually a lot of fun to work with a great group of people and do something very cool.
Well, I would bet because they're all highly educated. They're all highly motivated, I would hope. And you're working towards something where you can see tangible goals. Certainly you can have setbacks if things don't go right. But yeah, I would bet that is. So that's one of the things I miss about being out of the military is you don't have that sense of team purpose and camaraderie that you do. And it's good to hear that that exists even at all those different levels. And it's good that we have a podcast like this one where we can shine the light on those things once in a while.
Something that people should keep in mind is what a successful test means. The thing that you're testing doesn't have to work right for it to be a successful test. For example, it might not work right, but if you've done a good test and captured the data, then you can take that data back and people can fix the deficiency. And that's a successful test. So tests are about meeting objectives and learning, not just showing that something works right.
That's an excellent point. Now, theoretically, you could take that to an extreme. If I've got a smoking hole in the desert and I'm walking back with my parachute, is it going to be pretty hard to call that a successful test?
Yeah. I mean, although if you're testing a missile, it might not be as big a deal if you make a smoking hole in the ground. But no, obviously, a key part of a successful test is safety. It's not just getting the data, it's safety.
Yeah. Well, and you want to reuse your toys.
Yeah.
We have one-of-a-kind aircraft here, hand-built in a lot of cases. And so we don't want to destroy all the avionics and, like you said, the telemetry devices that are in those. So, well, all right, Ken, I feel like we could continue to go on with all this and maybe, at some point we can cover some of the other stuff, but really appreciate it. That was good.
Thanks. I always like making contributions to the Fighter Pilot podcast community.
Well, you do a good job. All right. Well, so let's wrap it up. First, we'll introduce our new Patreon supporters. We have Strike Lead Brandon Abrams. We have 2 mission commanders, Brandon Parr and Alex LaFlamme McFall. And then a new air boss, Lucas Graham. And that is our highest tier. Thank you, Lucas, and all of our air bosses, but really all of our Patreon supporters who help keep this show going. You might remember that the views expressed in this presentation are the personal views of the hosts and our guest and do not necessarily represent the position of the Department of Defense, its components, or, and I'm adding this just for you, Ken, its contractors. Because you asked me to put that in for Bomber Month because you want to make sure no one misunderstands who you're representing, right?
That's right.
You're just Ken Katz.
That's it.
All right, Ken. Well, I really appreciate you lending a hand here to the show with that interview. You did a nice job helping us better understand U.S. Air Force flight test engineers. Thanks so much.
Thanks again.
Okay. You have before I let you go, any other topics up your sleeve? You're always welcome back.
Oh, yeah. I've actually got a lot of things I'd like to do, all of which have to do with how different aspects of aerospace engineering affect military aviation. Because in the end, we serve the listeners. What I'm looking forward is feedback on this episode and what people liked and what people didn't like, and use that as guidance. And we'll see how we can apply that towards making some more episodes.
That's a great idea. So we always announce new episodes on Twitter, Facebook, Instagram, and then, of course, the YouTube version is there. So jump on social media or just send us an email and let us know what you thought of the different subjects. And if you want to take any pot shots at us, you're certainly welcome to. As we talked about before, Ken and I have a slightly different style, but that's a good thing. If we were exactly the same, it'd be redundant. So really appreciate it, Ken.
Thanks again.
That will do it for this week. We'll see you all right back here in 10 days for our next feature episode. And if all goes to plan, you will learn about air traffic control around nuclear-powered aircraft carriers, courtesy of a guest you DCS players might recognize whenever you fly around the ship. And the rest of you might also recognize if you saw the 2008 PBS series Carrier, particularly the pitching deck episodes. Until then, be well, take care, and send prayers for Ukraine. And if you don't pray, well, then send ammo. We'll see you.
You've been listening to the Fighter Pilot Podcast, brought to you by BBR Productions. Got a question for the show? Email us at questions@fighterpilotpodcast.com or leave a message on our listener line at 877-MACH-101. That's 877-622-4101. Be sure to follow us on your favorite social media platform and check out our website, fighterpilotpodcast.com. For exclusive content and to help support the show, check out our Patreon page. Thanks for listening.